In our earlier recording, we proved that there are two independent variables and they are uncorrelated. But supposedly, in case if there are two uncorrelated variables, we'll create an example in which we'll show that they may not be independent. So supposedly, x is a normally distributed variable with mean 0 and variance 1. And the relation between y and x as y is equal to x square. Now, clearly, as you could see, y and x, they are not independent. Okay, in case if you know y, you also know x, and if you know x, you also know y. So y is dependent upon x. Okay, y is dependent upon x. Okay, now as far as normal distribution is concerned and the way it is distributed, mean of x is given to you as 0. For normal distribution, even the third movement around mean is equal to 0. So ex cube is also equal to 0. That is mu 3 is equal to 0 for normal distribution, just because we'll be using it. Now, covariance xy. Okay, covariance xy. What we'll show is that covariance xy would be 0. That would imply correlation would be equal to 0. But still, correlation being 0 doesn't mean that x and y are independent. Okay, here what we'll show is that covariance of xy is equal to 0. Let's see how. What is covariance of xy? E of x minus x bar into y minus y bar, which will give you E of, on simplification, you can write E of xy minus E of x into E of y. This is what you'll have. In place of y, you can write x square. Okay, or what you can write is x cube also. Okay, in place of y you can write x square, so x into x square is x cube minus E of x into E of y. Now, we have already seen E of x cube is equal to 0 because E of x cube is third movement around mean, which is equal to 0 for normal distribution, minus E of x, we've already assumed it to be equal to 0. So it is 0 into E of y. So all of this would be equal to 0. So what we have seen is that covariance of xy is equal to 0. What is the correlation of x and y? Which is covariance of xy upon sigma x into sigma y. But what is covariance of xy? This is equal to 0 upon something which will be equal to 0. So what you have proved is that correlation is 0. They are uncorrelated, but they are not independent. As you could see, y is dependent upon x. Okay.